Now we are going to see, like as we know that what is polarity now, we are going to look for the applications of the dipole moment, like by just looking at the dipole moment what you can actually get to know. So the first thing is that you get to know that whether the given bond is polar or non-polar, because I told you that we have a non-polar covalent bond also, we have polar covalent bond also. So by just looking at the dipole moment you can see that yes, this molecule is going to possess the polarity. Second is that we get to know about the cis and trans polarity. So as I have a question for you here, see, this is my cis isomer, isomer, and this is my trans. Cis is that in which the two similar groups are facing, they are present in one side and the other is on other side. And like when the two similar atoms are present opposite to each other, that becomes trans. So this is my trans and this is my cis. So it makes us familiar that out of cis and trans, which is going to have the polarity or not. So just see here, if I consider the electronegative thing one, so this is more electronegative, this is more electronegative, out of them this is electronegative and this. So that means it is just going to have some additive effect, because it is not cancelling something. But in this case when we see that it is more electronegative, it is. So here we get to see that, see, the dipole moment of this bond is just being cancelled by this bond because they are in opposite direction. So that means it tells us about the polarity of the cis and trans bonds. Other thing, it tells us about the symmetry of the molecule. If there is a, you can say a polarity, like if there are two or more polar bonds, this molecule is not going to be symmetrical, it will be somehow unsymmetrical. So it just tells us like whether the given bond, whether the given molecule is symmetrical or unsymmetrical depending upon whether it has a dipole moment or not. One more question I have for you. So this is something that means a dipole, like this is my chlorobenzene in which there is a substituent chlorine. So here you can see that is orthochlorobenzene, this is metachloro and this is parachloro. So what do we get to see here? Here the two, you can say the negative group are close to each other, right? So they are going to possess the dipole. Again, this is also going to possess the dipole, but in this case, as you can see that they are just cancelling each other effect. So that means for para molecule, the dipole moment is going to be 0. So this is what we have, the dipoles and the polarities and the Debye unit. So this is what is the polarity. Now this thing must be striking in your mind that like earlier we were considering the covalent bond formed by the mutual sharing of electrons, right? But what we get to see that there also charges are present, there also certain charges are present, though the magnitude is less but still the charges are there, right? So that means the covalent bond, like after studying the polarity and the dipole moment, we came to the conclusion that the polar covalent bond actually possess some ionic character, because they have charges though the magnitude is less, but still it possesses the ionic character. So it is possible actually that covalent bond has certain ionic character, Now I am just going to make you familiar that we also have this thing covalent character in an ionic bond. So there is a possibility, like as we saw that covalent bond possess the ionic character. So by studying polarization, I just want to make you familiar that even the ionic bond can possess the covalent character. See how? As we know that ionic bond is formed between positively charged ion and the negatively charged ion. We know that, right? So what happens when the cation actually approach the anion? The ion with positive charge is cation and with the negative charge is anion. So when cation approach the anion, what happens? It attracts the electron, for a moment we can say that it attracts the electron more towards itself. So that means this molecule no longer remains spherical, it somehow gets distorted like this. It gets distorted. So that means some amount of positive and some amount of negative charge is being cancelled, or you can say it is getting neutralized. So that means if the some amount of charges are getting neutralized, so that means they are developing somehow the percentage of covalent character. So this is what is the polarization, right? So if somebody is going to ask you about polarization, you will say that this phenomena actually explains you that the covalent character, the ionic bond can also possess the covalent character. How now? when the cation approach the anion, it will attract the electrons, we assume that, right, that it attracts the electron of the anion more towards itself. So as a result, what happens, the anion no longer remains spherical, it somehow get distorted like this. So the you can say the electrons that get distorted actually, so that means some amount of negative and positive charge is being cancelled, and we know that where the charges gets cancelled, so that means it possesses certain covalent character, because the covalent bond is the bond which do not possess any kind of charges. I am talking about the non-polar one, right. So that means the ionic bond can also possess the covalent character, and that is given by something, polarization. Now there are certain rules, like as we saw that the cation is capable of polarizing the anion, right. So that means the cation possess the polarizing power. So now on what factors the polarization actually depends, that is given by the Fizzan rule, that is given by the Fizzan rule. So what does Fizzan rule states actually? It states that smaller the size of cation, more polarization we get to see. Obviously if it is smaller in size, that means charge density is going to be great and it will have more polarizing power, it is capable of distorting more anion toward itself, right. The second is that larger size of anion will favor the polarization. Obviously if it is of larger size, that means the nucleus is not holding the electrons tightly, and if the nucleus is not holding the electrons tightly, that means they have the power to distort more, and where the distortion is more, that means the covalent character is more, that means the polarization is more. Third, greater charge on cation. We know that if the positive charge intensity, suppose I have Na positive and here I have Mg2 positive. So out of them, obviously this is going to show more polarization, because being having more charge means it is more smaller in size, more charge density, more positive effect it has actually. So it is going to attract electron with more power. Right. So the fourth is, if the cation has 18 electrons in its outermost shell, that means it has a pseudo gas configuration, it is capable of more polarizing, right. So that means these four rules, that is the smaller the size of cation, larger the size of anion, greater the charge on the cation, and the pseudo gas configuration of cation, that is the Fizzan rule, just favors the polarization. So we have just reached on the conclusion that no bond is completely ionic or no bond is completely covalent. So that means the covalent bond can also possess the ionic character, and even the ionic bond can possess the covalent character. So that what matter actually, the thing that matter is the difference in the electronegativity, right. So if we take into consideration a specific value, if the electronegativity difference between the two atoms is 1.9, so we say that this bond has 50% ionic character and 50% covalent character, right. I will write for you. Suppose I say this is a bond, right, formed between two atoms. If the difference between their electronegativity is 1.9, so that means it is going to possess 50% ionic character and 50% covalent character. But if the electronegativity difference is more than 1.9, so that means that bond will be totally ionic bond. And if it is less than 1.9, so that means there are hardly any difference in the electronegativity, so shared pair is going to remain in the mid, so that is something covalent bond. So we can say that ionic bond is actually an application of covalent bond. We can say that ionic bond is actually a application of covalent bond, which we get to see when there is a difference of electronegativity between two atoms is more than 1.9, right. So just keep in mind that no bond is purely ionic, no bond is purely covalent. We have covalent bond, and depending upon the electronegativity we divide into polar and non-polar, and if the electronegativity exceeds a certain limit, it completely transforms into a ionic bond, in which the electron is totally lost and the one totally gains that, right. So this is what we have the polarity, this is what we have the polarization, this is what is the dipole moment. We have already done the bond order, bond length, and the bond enthalpy. So these are all bond parameters. Like if I ask a student, like if I ask you, like if you are a 10th or 11th standard student and I ask you about your parameters, I ask you about the student parameters, so that means you are going to say that yes ma'am, my name is this, my class is this, my subject is this, my percentage is this. So that means those parameters are just defining yourself as a student. So likewise here we have the bond parameters. These properties actually which we did are just trying to explain you about the bond characters, or they are just trying to describe a bond completely. So this is what is the bond parameters. So now we have done the ionic bond properties also. So we have done almost the bond parameters and all the polarities and the covalent bond. So we are now in a position to look at the properties of the covalent bond. So as we saw that there doesn't exist any strong Coulombic force, so that means they can exist in 3 states. They can be solid, they can be liquid, they can be gas. Otherwise, when we talk about the ionic ones, they were completely solids because they have a strong Coulombic interaction between them, right? Because their forces are not so strong, as they possess only weak force, and that weak force is van der Waals force. This we will discuss in the next chapter. Right. So for this moment, you just note this thing that it possesses a less force of attraction, right. So due to that, it possesses the less melting and boiling point. And when we talk about solubility, we know that like dissolves like. So as they don't have, like if we talk about general covalent compounds, they don't bear any charges. So that means they are not polar, right. So that means non-polar is soluble in the non-polar one. So they are soluble in the organic one, not in the polar solvents like water. And they are actually poor conductor of electricity because they don't bear any charge, and their reactions are molecular reactions which are actually slow if we compare it with the ionic reaction. So this is what is the difference that exists between the ionic compounds and the covalent compounds. So now I think you know that how to make ionic bonds, you know that how to make covalent compounds, and even you know that you are aware of their properties also, and even you know that what factors actually favor them. So now we have just finished with the first theory, that is the Lewis one, and now we are going to consider another theory which will just try to explain us many limitations of the octet rule as we went through many limitations. So it is just trying to explain you the all those limitations. So we are just starting with another theory, that is the VSPR theory. Though the name seems to be quite difficult, but the theory is very easy. It is VSPR theory, valence shell electron pair repulsion theory, right. Just look at the board.